Good evening, folks. Ethan Jones, AI Cloud Solutions Architect at Microsoft. I'm also the Machine Learning Adoption Lead for the UK. What essentially that means is I talk to customers across all different industries, public sector, retail, insurance, everything under the sun, about the importance of not ignoring traditional machine learning. When I was in my final year of university, some clever folks based out of the States published a paper about transformer models, which kind of changed the world, for better or for worse. Haven't quite decided on that yet. So I focus on not a lot of the generative AI stuff. To be honest with you, I kind of find it mundane in a way. There's only so many RAG chatbots you can build in a lifetime without losing the will to live, right? So I focus on more of the traditional data science, traditional machine learning stuff, because I mean, that's where you go down a rabbit hole. That's where you have an existential crisis, right? So I've been working at Microsoft about 4 years now. And I'm here to talk today about kind of the blend of those two worlds, augmenting agentic solutions with bespoke machine learning models. Rough agenda. I appreciate I'm short on time. I'm going to rattle through the slides. There's only about 8 of them. I've got a demo at the end as well, and a load of resources as well. So this is all open source. Started building it out of one of my public sector clients, but feel free, have a play around. It's all on GitHub, all open source. So we're going to start with traditional machine learning, and I always keep the traditional there because some people say it's not traditional, it's always been machine learning. Other people have said, well, that's all I know because I'm a software engineer and now all I do is I just build chatbots. So traditional machine learning, what is it used for? Where is it used? Every single customer that I've spoken to across every single industry does have a machine learning model deployed, whether their folks know it or not, right? So we're talking things like forecasting, so time series forecasting, weather forecasting. The Met Office have far too many forecasting models out there for their own good, but hey, classification, red or green, anomaly detection, optimization. Some of those problems can also be solved by generative AI. We'll go into the next slide about why that probably shouldn't be the case in the Swiss Army knife paradigm that I'm seeing in a lot of organizations. As I say, deployed in pretty much most organizations. Insurance, there's fraud models, there's pricing models. In retail, there's the supply chain forecasting, all sorts of different things. It's all around us. Deterministic by design. Nobody's shouted at me, that's fine. We're not going to go into the rabbit hole of whether large language models are deterministic or not. I always hate that conversation. But machine learning models, the kind of paradigm is A always equals B. If you put something into a machine learning model, it's always going to output the same thing. You ask ChatGPT who the funniest person in this room is, he's never going to say me, but he's probably going to say 5 different people, right? That's one of the beauties of traditional machine learning. Whether it's deep learning or shallow learning, doesn't really matter. It's always A equals B. Explainability. So epistemic uncertainty, and what I mean by epistemic uncertainty is the uncertainty within the black box of the model itself. It's quite, easy, it's quite trivial to explore and map that out in traditional machine learning models. Whether it is, as I say, shallow machine learning or even deep learning models, there are a load of techniques out there for being able to understand how did the machine learning model come to this decision and why. What features are most important, so looking at things like SHAP, and feature importance. Why did it get to that decision? Now, yes, there are things you can do with generative AI models to be able to kind of get that similar sort of thing. It's an absolute pain, and the research isn't there yet, right? So traditional machine learning, very trusted, very, very robust. And as I say, GPT 3.5 came out about kind of 5 years ago and kind of changed the game. And software engineers have kind of taken it upon themselves to start developing things, and without really understanding under the hood what it's doing, how it works. And I'm a firm believer, whether folks are going to be using large language models or traditional machine learning, the best data scientists or folks that dilly-dally with large language models, understanding the statistics is going to put you way ahead of the game. Because that way you can understand, actually, this is probably why it's gone wrong. This is why it's probably hallucinated. Can we fix that? Yes or no? So large language models optimized for language, hence the second L in the name of large language models, not numbers. Trained on huge corpuses of data taken from the internet, all text-based, right? So if we think about something like a weather forecasting, right, that takes all sorts of different features, whether it's wind direction, all sorts of things, Large language models, yes, there's probably some people out there that have written really detailed blogs and all sorts of things about how it works that, these models may have been trained on. But in terms of very large tabular data sets, that pre-training doesn't necessarily mean that that language model is going to understand what you're doing at all. Yes, you can try and fine tune it. Good luck finding the budget to do that. Have fun having the conversation why that doesn't work. But they are essentially trained on the next token. They predict the next token. The cat sat on and that's essentially what it does, right? So if we're forecasting something with a large language model, there is a potential that if the corpus is small enough and has been corrupted in a sense, and we say, right, I've bought 4, 5, 6 apples for each day, the next one intuitively 7, but somebody out there in the corpus has then put 554, it could quite easily predict that as the next token, right? It doesn't understand it. Now the outputs are probabilistic, as I say. There is an argument about non-determinism and determinism with large language models. We're not going to get into it. And agents should reason, tools should predict. And that's where we start looking at leveraging things like MCP, which again, it's kind of taken over the world because some clever folks at Anthropic came up with it. But it's essentially an open protocol. It saves us writing connections and all sorts of middleware for connecting our agents through to data sources, tools, functions, all sorts of different things. Now there's 3 different primitives: tools, resources, prompts. Going to focus on tools. And we're going to look at machine learning models as tools to augment the capabilities. Now, when we get into the demo a little bit later on, if I actually keep to time, the agent doesn't understand the underlying model. It knows the kind of schema, it knows the input schema of what to put into the model. It doesn't understand what XGBoost is. It doesn't understand the jokes about why XGBoost is going to save the world. It has no concept about it, right? It just knows that I've got to input a reference ID and a date. That's all it needs to know for us to be able to interact with it. Now, a couple of different ways of doing it on Azure. You look at a lot of our architecture diagrams in the Architecture Center. They kind of use container apps and functions. There's pros and cons. We're not going to talk about it here. But for the demo that I'm going to show, I used Appium, so Azure API Management, and the native MCP capabilities within that. And it translates to something like this. Yes, that will play on repeat, by the way. But this is the kind of reference architecture that we're working with here. Now, this, for any data scientists in the room, does abstract the very painful process of actually doing the data science process of feature engineering, EDA, training the model, hyperparameter tuning. It abstracts all of that. For better or for worse, depends on your point of view. But we essentially are taking a forecasting model, and the use case, I'll redact it, but let's say it's a retailer. They're looking at updating and making sure that they're ordering the correct number of apples for their stores. Let's go with that. It's essentially the sort of problem we're looking to address here. So minimizing waste and optimizing the supply chain is essentially what they're looking to do. So we take a machine learning model and we deploy it to a managed online endpoint, meaning for real-time inferencing. This paradigm works for Databricks or wherever else you want to deploy your machine learning models, but essentially for the paradigm to work in a chatbot environment, we need that inference to kind of be real-time, because if you have it as a batch pipeline that takes 24 hours to run, you kind of defeat the whole purpose of having it service in the chatbot anyway. You can obviously have it in a deterministic workflow, but hey, for this example, real-time. Everything is more or less directed through Appium. So we'll see when I go through the demo, we have 2 APIs, one for managing the inferencing to the GPT model sat in Azure OpenAI. So we can look at things like token usage, we can have that retry logic, we've got that observability there. And then we also direct any tool calls through Appium as well, so we can have a look at the Azure Machine Learning and inference the Azure Machine Learning model as well. Now, traditionally, before the agentic world came about, a lot of folks would integrate their machine learning models via kind of really old, terrible UIs, which I guess is fine. It still does the job, right? And it poses the question, why don't we just call it directly? Why do we need to put it in an agent to begin with? The value really isn't necessarily just having a natural language interface to call the model. The value comes by having that agent as part of a wider agentic system that connects to, I don't know, documentation. So one of the examples that I'm going to talk through, one of my customers is looking at their pricing models and having that in a chatbot for their call agents. So when somebody phones up and says, I've had enough of you, What can you do me? Natural language, yes, they can call the pricing model, but equally, that system is part of a multi-agentic solution that can call out also all of their previous claims and everything. So they have a single pane of glass view of all of the customer information, but also pull additional information instead of having them go, give us a second, Alt-Tab, and then go to the UI that has that pricing interface. It's all in one. So it kind of modernizes that surfacing layer of the solution. As I say, a couple of examples that we've got that I'm currently working with. The top one is probably the coolest one, if I'm honest. An organization, so they've got a load of sensors, and when I say a load, they have a ridiculous amount of sensors. And they're looking to create kind of a smarter building solution. Their aim is when they have workers looking to do like predictive maintenance and things like that, they can phone up the building. So because we are moving towards agentic solutions, some of these models are multimodal. We can interact with it via voice. So they can go, right, I want to talk to this specific building, I want to talk to all of these sensors, and then using that sensor data, we built a forecasting model that is connected to a chatbot that I can interact with my voice. Ridiculous. Absolutely crazy. I've put on there it's to inform whether the light should be on, but there's predictive maintenance. You know, they hire out some of the rooms as well and things like that, but absolutely crazy. All built on Azure as well. Kind of alluded to number 2 already. Number 3 is quite interesting as well. It's another voice-enabled kind of stock management system. That's already live. Very, very interesting there. And number 4 we've talked about before, right? With those kind of pricing models having that single pane of glass view. Before I go on to the demo, and I do have time, resources. If anybody's interested, feel free to have a look. As I say, it's all open source. For those of you that are interested in kind of MCP servers and Azure API management as a kind of middleware for AI agents, that third link there to the AI Gateway repo is probably one of my favorite repos. Has all sorts of different patterns and labs that you can have a look through, have a play around with, and all sorts of bits and pieces. But I'm going to walk you through one of the labs that I built out the other day with a good friend of mine by the name of Claude. Some of you may know him, some of you may not know him. No, his name is actually Claude, it's not the other guy. But going to walk through the example of the end-to-end demo. Now, I am short on time, so I'm going to rush through it a little bit, so we have at least a couple of minutes for questions at the end. But as I say, all of it is open source, so have a play around with it yourselves. Right, where shall we start? Let's start with the resource group. As all good things start. Is that too small for those at the back? I see somebody squinting. Are you sure I can? It's not a scratch off my back, it's fine. It's quite small. I appreciate your honesty. Awesome. So, now, mainly because most of my day-to-day is spent in Azure Machine Learning, I've essentially just deployed Azure Machine Learning, and that's where my model is being deployed. But this is essentially all infrastructure as code. I did use Bicep. I know there's quite a few Bicep haters out there in the world these days, but I did use Bicep, not by preference. As I say, it's what Claude chose. But I've got a Foundry instance. We don't necessarily have to deploy our agents via Foundry, but hey, we're an Azure User Group, we might as well use Foundry, especially because we don't know what's in GA and what isn't in GA. That's always the funnest part. But essentially, the main things to bear in mind here, the Azure Machine Learning workspace, which has dependencies on the container registry. So we Dockerize the image when we deploy it, and we can see the endpoint and the actual model deployment there. We have the application insights, the key vault, and the storage account. Again, all dependencies for the machine learning workspace. And then we have the Foundry and the Foundry project and the APM service as well. Now, within the APM service, if I quickly go to my APIs, won't go into too much detail. I've got the 2 APIs here, right? Bearing in mind that all of the traffic is going through that middleware. We have one for the model inferencing. So every time, I think it's GPT 4.1 or whatever it is, doesn't really matter, kind of beside the point. But that's all being logged and sent through APM, so I can look at token usage, I can put policies. I think I've got exponential back off as well if there's something wrong. But then I've also got the API for the machine learning model as well. So all of it is going directly through there. Now, as an example, And I've just realized that I didn't copy and paste the payload for the model. But hey, this is the online endpoint. So this is the model that I've deployed, taken a SKU. It's authentication type. So we're going to be using Entra. There are no keys in this example. Well, there are some keys, but that's for the machine learning workspace dependencies, beside the point. But we're using managed identity kind of authentication to make sure that everything's secure and going through. And then the end goal is something that looks a little bit like this within Foundry, where we've got our agent name, ML forecast. We've got a specific model, we've got some instructions, it's just a simple prompt. And this is essentially going back to the point of, it doesn't need to understand the underlying model, it doesn't need to understand that it's trained on an XGBoost model. Essentially, we have 2 columns, the ref ID for the distributor and the scheduled delivery date. In all fairness, I haven't put in some other parameters in there, but that's essentially now, anytime that I interact with that, it will look through the MCP servers it has available to it. Shock horror, it's only got the one, and then we're able to kind of inference that and have that surfaced. So how this looks, as I say, don't have a lot of time, so you're going to have to forgive me here. If I can remember how to actually zoom in. There we go. As I say, all of this is in Bicep. All of this is, as I say, open source, including the model. So the model itself, you don't need to know data science at all. It just kind of plugs and plays. Even the MCP server is defined in Bicep. So it's all there, ready to go. And I have a little bit of a playground notebook here. So if you give me 1 second just to initialize the parameters and just make sure that I have all of my extensions installed. Fantastic. And then if I get the outputs, it's always fun when it takes longer than it should. How difficult is it to get a couple of parameters? Brilliant. So I now have fetched all of my information from the deployment. I'm not going to register the model, but this is the cell here that would register the model. It would take the output, trained in MLflow, and deploy that to a managed online endpoint. And now I can inference the model directly using code. So if I show you this input data here, we can see that I have, as I say, going back to the instructions on the agent, got the columns, the distributor ref, and the scheduled delivery date. So an arbitrary number, doesn't really matter. And then the date, I won't run that because it takes about 40 seconds. But we can see here the output is kind of 18.75. So based on my training data and the pattern it's learned across, I think it's 3.5 years worth of data. Don't need to get into best practices of the model training, but it's predicted 18.75. Bananas, apples, doesn't really matter at this point. So that was going directly to the endpoint itself. Now, going via Appium doesn't really change too much. From my testing, it actually makes it about 30 times faster. I'm going to blame my mobile data for that. But I can send a similar sort of payload here, exactly the same, and we get exactly the same output to show that we have that kind of deterministic nature between the two of them. So now I'm going to show the example of, we're going to Appium and we're looking at all of the MCP servers that we have, and the available tool that we have is this kind of predict forecast, and we've got a little bit of description that kind of shows invoking a managed online endpoint to generate a time series forecasting prediction. Now obviously there may be other MCP tools that are available and things like that, but I now have a little bit of code that looks at using the OpenAI agent SDK. And if I go down to here, the instructions, pretty much, you're an AI system that helps with delivery forecasting. It's kind of similar to what we saw in Foundry, right, with that agent definition. And then we can see this plain kind of natural language text here. What is the predicted delivery quantity for an arbitrary distributor and a random date? I had to rewrite the date when I did this demo to a customer because they just assumed that it was just taking the same schema and just putting it in. But now what we should see And I will say that most of the latency from this, that was actually quick for a change, most of the latency will be on the GPT side. The actual inferencing of the machine learning model is instantaneous, really, really quick. So we can see here the predicted delivery quantity for a specific ID on a specific date is the certain units. Now, obviously, if we think about it, we could quite easily integrate this with a SQL database that actually looks at the inventory, and we can almost have some kind of self-correcting multi-agent system that goes, actually, you don't need to order 19 units, because if I look in the SQL database, you have 500. Why do you need 19 units for this date? So, as I say, the value is very much integrating that with other services. I won't run this next piece, but this is where we create the agent, the Foundry agent. I guess the cool thing here is it had a little bit of a hard time inferring the schema when I tried this earlier, where created the agent absolutely fine, created the MCP server. I need to provide the prediction request with the required format, let me correct it and try again. So it self-corrected itself. So the first time it tried to input the wrong schema, I don't know what it tried to put in, we can obviously have a look in the logs to see how it tried to call that MCP server, but it self-corrected it. So pretty cool that it's managed to do that. And again, we get the same output. So we've called the same model with the same input 5 times. We've got the same output, at least on the forecasting side. On the actual text side from the large language model, I mean, there's only so many ways you can actually say the same thing, but we can see it's kind of worded it 4 or 5 different times as well. And all of this, because we're connecting it up to a log analytics workspace, again, won't run into it, but we can essentially have all of the logs and the token usage as well, all in a single pane of glass view. So the power of having Appium in the middle of this, being able to do all sorts of bits and pieces, even load balancing across different regions if we wanted to, load balancing across different models, all sorts of different bits and pieces. But it means that we can have that centralized view of all the logs as well. Thank you.